LED bulbs, they're great, aren't they? Low power, reasonable intensity. But if, like me, you've decided to buy a lot of these LEDs, you probably would have noticed by now that they're not terribly reliable. And I must have had about 2 dozen of them start failing. They either go off completely or they start flashing.
Either when they're cold or when they've got hot and warmed up a little bit. Very annoying. And since LED bulbs are still reasonably expensive, the cheapest ones are about £3 or £4, but very often you see them for sale for about £15 or £20, $20 or so, I guess. Then if we can fix some of these bulbs, then it's worthwhile doing. And I found some of them can be repaired by testing the individual LED light components within them and finding out whether the individual ones are good or not, and desoldering the bad ones and replacing them with good ones from another bulb. So this is the essence of this video. Some of the early bulbs, it was mainly the drive electronics that would pack up, and taking the bulb apart and looking at them, you can see some rather overheated components as a result of some poor quality design. Those ones it's best to just chuck in the bin, because trying to fix the drive electronics is not really worthwhile in terms of the amount of time it would take. But on the later groups of bulbs, I found it's the individual LEDs that tend to age and malfunction. And where a unit contains 3, 4, 5 LED components inside it, it's possible to test the individual LEDs and replace them with good ones from another bulb. Even if that other bulb originally had some problems, it won't be all of the LEDs that have gone bad in them. So that's the essence of what we're going to do now. Shows a technique for testing the individual LEDs, taking these bulbs apart, and then we'll desolder the LEDs, having found some good ones, and replace the bad ones in other bulb units, and get back to some working LEDs, hence saving some money. So it's not always possible to get every single LED resurrected, but certainly should be able to get quite a few good LED bulbs out of a bunch of bulbs that have failed. Before we do that, just to show you what the bulbs look like when they're failing, here you can see one flashing away at a rather random time, a little bit dim in between the flashes, and here we see one that's just a lot dimmer than normal. So you'll need a multimeter with a diode test ability on it, a little symbol of a diode which has an arrow with a line on it. The diode range basically means that it'll put a small voltage across the probes, and we can use this to test whether the LEDs work or not.
When we attach it the right way around, you see the LED actually lights up, shows that a small current and voltage is coming out of these pins. Not enough to make it shine brightly, but the first test to do on all these LEDs is to make sure they basically function, which they seem to do. So far so good, but we know that something is wrong with this unit, and so we need to drive them a little bit harder, because what we found with this one is it only started flashing after a few minutes when it had warmed up. So next thing to do is we'll put that on our current measuring range, 10 amps. Got a couple of rechargeable batteries. They're about 1.26 volts each or something. Two of them in series gives about 2.5 volts, which is about right to light up these LEDs. Normally you'd put some sort of current limiting resistor in series with them, but I believe that these should be able to deliver not too much volts, just about the right amount of voltage, not too much current. So I'm not going to bother with current limiting resistors. Let's just pop my lead back into the negative side again. Okay, so it's a quick lash up. As I say, 2 rechargeable batteries. So now we've got a slightly higher voltage and current source than just the multimeter. By having this on the current measuring range, this is effectively like a short circuit, so there's very little resistance between these two wires. So it's like applying the full battery voltage across the LED. So I'll just get something to hold the LED. And we can now, making sure you get it the right way around, the LED won't light up if it's the wrong way around, you won't do any damage to it, it only conducts one way. We can now start to apply, let's swap these over, make sure I get it the right way around, a slightly higher voltage and current. Now you see that LED is lighting up, not fantastically bright though. Check the next one. Now that is a lot brighter. Hope you see the difference. And that one is a lot brighter. And this one is a lot brighter. So the odd man out is this slightly dim LED, which leads us to suspect that it's just this one LED module that's causing all the problems. So what you can quite easily do is just desolder these two pins, get another unit, dismantle it, take the LED out, because they're all the similar type of construction and design, and resolder that one in, and let's see if it fixes it. The other thing you will find is the operating voltage and therefore the current of these LEDs will vary between manufacturers, probably between batches. So here we can see very bright, let's get a good connection, getting a very bright response at about 14 milliamps. Whereas before we either have with different LEDs you either get 2.5 milliamps and quite dim, 5 milliamps quite bright. Important thing is to make sure they're all well matched in terms of brightness and current. These are quite well matched, but there's one that takes no current at all and has no light output, so this one is obviously the faulty one. So I continue looking around until you can find another bulb with the same LEDs, same voltage, same current. Swap the LED over until you can get LEDs that match. So your best chance of success is to go through and test the LEDs, wait till you find one that's not lighting up or is very substantially different intensity, and then find a bulb of the same make or manufacturer and same voltage of LED, and take one of the LEDs off that board to replace the faulty one. That's your best way, it gives you the best chance of fixing the units. Okay, so there's the bulb back in position and seems to be working nicely. I'll give it a full 5 or 10 minutes to make sure that it's working stably. So after 10 minutes it's still good, and that seems to be a fix.
You won't be able to get 100% success rate, but you should be able to get a few working bulbs out of a batch of bulbs by changing the individual LEDs. Thanks for watching.